Hello everyone, I'm Naveen Agarwal and I want to welcome all of you to my weekly video update. This week, I want to share some thoughts with you on a key topic that keeps coming up related to ISO 14971, the international standard for risk management of medical devices. Now, this topic has come up in my monthly interactive Q&A sessions quite frequently. Oh, by the way, if you are not familiar with my Q&A sessions, I do this every month where we just get together with colleagues from our industry to discuss questions, share best practices, ideas and insights on key topics. It's free to attend and it's a very informal forum. So all you have to do is sign up and show up and engage with us in a conversation. So keep an eye on my LinkedIn feed for announcements of upcoming Q&A sessions. And if you want to check out what they are like, there are some recordings of past sessions on my YouTube channel. You can look them up. So this topic comes up quite frequently, and in the last couple of sessions, we have had pretty robust discussion on this. So I wanted to share some thoughts with you. Again, the idea here is to continue our conversation and look at this topic from different angles. This topic relates to assigning severity levels to harms. As you are all familiar, ISO 14971 requires us to identify hazards, hazardous situations, and harms applicable to our medical device within the context of its intended use. We have to do that. And part of the exercise is to assign a level of severity to the harm. How do you do that? Now, we know we should be working with professionals with medical expertise or clinical knowledge related to our device and the procedure that might be involved with it. We need to be working with that. But how do you go about actually assigning a level of severity or more than one level of severity? What is the best practice? So I want to discuss that in this particular video, share with you some ideas. And again, the intent here is not to say this method is better than the other method. I want to actually propose to you 3 different approaches. And it's up to us to decide what might work best in our particular situation. So there's no specific recommendation. It is just a proposal, an idea for you to consider. And I would love to hear back from you. Let us discuss what has worked for you in the past. Maybe all of our colleagues can learn from each other. Okay, so let's look into this. This is the question people are struggling with, and they have asked several times. If any harm can eventually be linked to death, should every hazardous situation be assigned the maximum severity level, let's say severity level of 5? Very interesting question, because yes, even a simple cut or a minor infection could potentially lead to death. Any situation that you can think of, there is a finite probability, even though it's very small, that it could lead to death, right? So we are faced with this scenario. If that's the case, how do we go about considering the right level of severity or more appropriate level of severity? So we will discuss that in this particular video. First, let's look at the terms. Severity is defined in ISO 14971 as a measure of the possible consequence of a hazard. So what's a hazard? Well, hazard is a potential source of harm. Okay, so what's harm? Injury or damage to the health of people or damage to property or the environment. So for the purpose of this conversation, we will focus on injury or damage to the health of people part, right? Similar conversation or logic could be applied to damage to property or the environment. But let's stay focused on injury or damage to the health of people. So that's what we are worried about. Let's first look at how hazards link to harms. This is very important to create a basic foundational understanding. So typically there's a trigger event. Something failed, maybe a device failure, or maybe not a device failure, something else. That starts this chain of events, which we call sequence of events, one after the other as a cascade, they happen. And that leads to a hazardous situation where the patient or the user is exposed to one or more hazards. And that leads to a harm. So this is kind of a chain of events that tends to happen. So we need to start thinking about an immediate outcome versus a final outcome. So let's say someone is exposed to one or more hazards in a hazardous situation, and there is an immediate effect. Maybe there's an injury. That leads to what we call medical intervention, potentially, which I also sometimes refer to in my conversation with people as standard of care. So something gets done when something happens. So there is more, not just an immediate effect. And the final outcome could be full recovery or death and everything in between. So this is the scenario that we should consider. Are we thinking about the immediate effect and how it translates to the final outcomes, which could be on a scale? How are we looking at it? Okay, so let's look at an example. False negative result from a COVID-19 test. This is very relevant today, and it's happening quite frequently, believe it or not. I have made several videos about these false negatives or false positive results from some of these rapid COVID tests. So let's look at this scenario. Here, the trigger event is a false negative result for an, let's say, asymptomatic individual. You get a false negative, they're actually positive, but the test is telling them they're negative. So what happens? There are no symptoms, no medical care, no isolation, right? That's a possible scenario. So hazardous situation here is that this person has been infected with the SARS-CoV-2 virus and they have COVID-19. There are several outcomes. The first outcome is, in many cases, they continue to remain asymptomatic and the patient recovers without any therapy. Good for them, right? And it happens quite frequently. However, since they are not aware that they are asymptomatic and have the infection, the public health risk remains unmitigated if they don't take the public protective measures like social distancing or masking. So that remains. Now, on the other hand, if they develop symptoms and they seek medical help, now the outcome could vary from full recovery to death. So let's look into that a little bit in more detail. So the question we're going to ask is, should this scenario be rated with the maximum severity level for death, say 5? That's a very important question for a test developer when they are doing their risk analysis. I want to review the linkages again, now in the context of some probabilities. So we talked about the trigger event leading to sequence of events, leading to hazardous situation where exposure to hazard happens, and then leading to harm. Now, up until the point of hazardous situation, occurrence of hazardous situation is what is known as probability of occurrence of a hazardous situation. Just because you have had a false negative result doesn't necessarily mean that the patient or the user or people around them are actually exposed to the hazard, which in this case is the virus or biological hazard. Okay, so there is a probability associated with that, P1. We usually call it P1. And you can look up TR 24971 for more details. Now, once the hazardous situation has occurred, there is another probability called P2, probability of the hazardous situation leading to harm. So you have some exposure with a probability of P1, and that P1 could lead to one or more P2s for one or more harms of one or more severity levels. That is the scenario we are talking about. Okay, and finally, you can calculate the POH as POH stands for probability of harm as the multiplication of those two, P1 times P2. You could do that. And you could do that for every severity level. So here is option 1. You could consider all outcomes, which on a scale of 1 to 5, let's simplify it, will be a total of 5 risks, right? So you have the hazardous situation where the person has COVID-19. One of the final outcomes could be continues to remain asymptomatic and recovers without any therapy. Another outcome could be develops symptoms, receives primary medical care, remains isolated and recovers. Another outcome could be experiences worsening symptoms and is hospitalized, recovers without any long-term effects. Another outcome could be experiences worsening symptoms and is hospitalized, needs ICU, intensive care, but recovers with maybe some lingering long-term effects. And the final outcome could be they experience worsening symptoms, hospitalized, treated in the ICU, but they die, unfortunately. And it is happening. So you could assign a severity level of 1, 2, 3, 4, 5 to these 5 different scenarios. Same hazardous situation is leading to 5 different outcomes of different severity levels. So you could do that. And then you could estimate a P2 based on some literature or some expert opinion. Based on what is going on and what we know so far, this could be an illustrative distribution of P2s. Maybe 10% on level 1, about 70%. Most people may receive some primary care and they recover, but about 10% of them are hospitalized, and 90% of those who are hospitalized, they recover. They might need some intensive care, they recover, and they might have some effects. But about 10% of those who are hospitalized may die. So here you have a distribution. You could consider all 5 scenarios as 5 different risks for the same hazardous situation. And this method is described in this great book I would recommend to all of you. It's Safety Risk Management for Medical Devices by Bijan Elahi. An engineer by training, Bijan has done a lot of work, and I've had the pleasure of many conversations with him. This is a very quantitative approach. If you have data around different probability levels, sure, get all 5 scenarios listed as 5 different risks in your risk analysis. That's option number 1. Option number 2 is consider the outcome with the highest severity, which is number 5 right here, even though P2 is quite low. Overall probability will be much lower than the probability of harm for severity level 2, right? But you could say, I'm going to take the most conservative approach and apply the severity level of 5. Because it is likely to happen, so I'm going to consider that. Another option could be that consider the most likely outcome, which is they recover after some primary medical care. So these are 3 potential options for you to consider. It depends upon the quantity and the quality of data that you have available for you. How well do you understand the linkages between your device, how it fails or how it operates in the real world, and how it leads to exposure to hazards, and what kind of final outcomes are observed. If you have data from, let's say, clinical literature or field experience or medical expertise resident in-house, you could apply the BXM method explained by Bijan in his book, and for every hazardous situation, come out with 5 different risks of 5 different severity levels. You could do that. But if you don't have that quantity of data or quality of data, you may have to make some choices. Do you go for the maximum severity? Do you go for the most likely outcome? But whatever you do, you need to figure out a way to continuously monitor what is happening in the field. And that is the post-market data gathering, analysis, and action requirement in ISO 14971. So my recommendation would be take a look at the quality and quantity of data that you receive from post-market surveillance. Take a look at your internal systems, how good they are in capturing that information, analyzing them, and helping you make that decision. In many cases, in my experience at least, where the devices are not life-critical or life-saving devices, there is hardly any probability of death. Life-threatening conditions may occur, but death is extremely rare, right? And we also don't have definitely associative or causative information from the device to the harm. In many cases, even if devices are returned, malfunctioning devices have been returned from the field, you do some analysis, all you do is they were made to spec, we cannot find anything wrong with them. So you cannot associate any issue with the device with the final outcome. In those scenarios, you have to make a choice, whether you consider highest severity for all potential scenarios or the most likely scenario based on medical judgment. And I have worked with doctors where they have intuitively applied this approach. Sometimes their approach is, no, for this particular scenario, we must consider severity 5. But for some other scenarios, 3 or 4 are sufficient. And then in your risk analysis approaches, you could consider 4 as the upper limit from their assessment. There are many ways to do this. So I don't want you to think that I'm recommending one approach versus the other. I'm just illustrating this for us to evaluate different approaches, work with our experts, look at the quality and quantity of our post-market data, because that's the most important part. how well are you going to be able to evaluate market information to see if the risk level has changed? If you're going to look at P2s in a quantitative way, you should have a mechanism to gather information to see if P2s have changed or not. So that'll be very important. And hopefully, this will strike some more ideas for you in your team. You can have more discussions. But I would love to hear from you. Does this make sense? Do you have other approaches that you utilize that you would like to share with everybody? Please leave a comment or engage with me in a discussion on LinkedIn. I'm really excited and look forward to your ideas, opinions, and questions. And that's the purpose of the interactive Q&As as well. So I hope you will look them up and join me in the next upcoming Q&A session. I want to thank you again for your interest and attention. And I look forward to seeing all of you in one of my Q&A sessions.